In this video, we want to find the multiplicative inverse of the matrix A, which in this case is a 3 by 3. Now in the last video I did one involving the 2 by 2 matrix. I went through a long procedure or a longer procedure, and then I went through a shortcut using the adjoint matrix. I'll link that video in the description. Now for this one here, I'm just going to remind you what the procedure involves. If I were to do this using row operations, I would create a augmented matrix. And it's just what I did with the 2 by 2. But in this case, you would simply put the 3 by 3 identity to the right of this. And then what you would do is simply use row operations. So you can add a multiple of any row to another row. And you want this 3 by 3 identity to appear on the left side. So you want this to be a 1, this should be a 0, this should be a 0, 0 here, a 1 here, a 0 here. You want a 0 here, a 0 here, and a 1 here. So you look at this whole thing as a matrix, and you use row operations to get these components to be, like I said, a 1, 0, 0, 0, 1, 0, 0, 0, 1. And if you can do that, whatever appears on the right side is going to be the inverse. That's what we did with the 2 by 2. I won't do it in this video, but that's what we did. And that's what you'd have to do if you want to use that method. In this video, I'm going to use the shortcut method. So what we need is the determinant of this matrix. We need the determinant. So we're going to look at this as a determinant. So I put the bars here, a bar here, and then what I'm going to do is use row operations or properties of determinants. So I'm looking at the determinant though of this matrix. So the first row stays the same, 1, -2, and 5. Second row stays the same, got a 0 there, got 3, and a 1. And then I want this component right here where the 4 is to be a 0, so I'm going to multiply the first row by -4 and add to the third. So -4 times 1 is -4, added to 4 gives me a 0. -4 times a -2 is a +8, added to -8 gives me a 0. And then -4 times 5 is -20, added to 2 gives me a -18. Now, based on some properties of determinants, because I have all the components below the main diagonal equal to 0 right here, I can get the value of this determinant by just multiplying the numbers in the diagonal. I could also expand using the components of column 1, and I would get the same answer. So here is 1 times 3 is 3, times a -18 is a -54. So in this case, the determinant of A is a -54. And there's other ways to get the value of the determinant, but for the shortcut method, we need the value of the determinant of this matrix, which is a -54. So we have that. Now we also need the cofactors of every component of this matrix. So I'm going to look at C1, 1. So the component in the first row, first column. And how we find the cofactor of that element here, there. Eliminate the row and the column that the element is. That's going to give me a 2 by 2 determinant here. So it's 3, 1 minus 8, 2. And because it's in the 1, 1 position, first row, first column, we start off with a positive. So this is multiplied by +1. I'm just going to put a positive here and then cross multiply. 2 by 2, we go 2 times 3, would be 6. And then it's minus this product. So it's minus a -8. That gives me a 14. So we'd simply replace this first element here by 14. And then it would just go down the row here. For the -2, that's in the first row, second column. So this would be, again, take away the row and the column. And what do we have left? We have 0, 1, or 2. And the sign alternates. So instead of plus, now we go to a minus. I'll put a minus right here. And then evaluate this determinant. Cross multiply, that'd be 0. Cross minus 4 times 1, that'd be a minus 4. And the sign here is going to be a negative now. So this would be 0 minus 4 is a negative 4, but it's multiplied by a minus 1. So this gives me a plus 4. So that cofactor for that component is a 4. And then I continue here for the 5 here. I want to replace that by its cofactor. So it's in the first row, third column. So I'll call this C13. And then again, the sign changes. It's plus, minus, plus. So this is going to be plus, or plus 1 times. I take away the row, take away the column. What's left then gives me the cofactor, which in this case will be 0, 3, 4, negative 8. Evaluate that. Cross multiplies at 0. And then that's going to be a minus 12. 4 times 3 minus the product. 4 times 3 is 12. Minus 12. The sign is positive, so that stays minus 12. And then I continue with the next one. And it keeps going for each of these components. And that is called the cofactor matrix. So I did the first row, and then we go to the second row, and then the third one, and so on. Just doing the same thing. And eventually I get, so here's the determinant and the cofactor then. We got the 14, the 4, and the negative 12 for the first row, and then I continue with the second row. And if I continue that way, I get negative 36, negative 18, 0. Then for the third row, negative 17, negative 1, and 3. And that gives me the cofactor matrix. So this is your cofactor matrix. Now, once I've done that, what I need then is what is called the adjoint matrix. So ADJ of A. And all that is a transpose of the cofactor. So if I take the rows of the cofactor matrix and make them into columns, so notice 14, 4, negative 12. The adjoint here, look at first column is 14, 4, negative 12. Make the second row a column. Negative 36, negative 18, 0. That's this one right here. And make the third row a column. Negative 17, negative 1, and 3. I get the adjoint matrix. Now once you've done that, to get the inverse of that matrix, here's your formula. A inverse is equal to the adjoint matrix A multiplied by 1 over negative 54. The negative 54 is just the determinant of that matrix. So here it is. This is your formula, and this is the adjoint matrix. So to complete this, you simply take every component of the adjoint matrix and divide it by negative 54, which is the determinant of that matrix. So for this one here then, it's just 14 over negative 54. So you can reduce that down, divide by 2 here and by 2 here, and then this would give me a negative, reducing the 14 over negative 54, give me a negative 7 over 27. Negative 36 over negative 54, the negatives cancel, and you can divide by 18 there, and you get 2/3 here. Negative 36 over negative 54 reduces to 2/3. And then negative 17 over a 54, the negatives cancel. That gives me a 17 over 54. And then 4 over negative 54 gives me a negative, and then reduce it by 2, divide by 2. This would give me a 2 over 27. Then negative 18 over negative 54, the negatives cancel out, and that reduces to 1/3. Then negative 1 over negative 54, the negatives cancel, and I get 1 over 54. Then negative 12 over the negative 54, negatives cancel out, and divide the 12 and the 54 by 6, and I get 2 over 9. And of course negative 54 into 0 would be 0. There's 0 here. And then 3 over negative 54 would give me a negative 1 over 18. So this is your inverse matrix. Negative 7 over 27, 2/3 for the first row, and then 17 over 54. For the second row, -2 over 27, 1/3, 1 over 54. And the third row is 2/9, 0, and -1 over 18. Now if you take this matrix right here and multiply it by the original matrix A, it'll give you the 3 by 3 identity matrix, which would have a first row of 1, 0, 0, second row of 0, 1, 0, and a third row of 0, 0, 1. Thanks for watching. We'll see you next time.